The year was 1977 when the greatest success story of modern space travel began. Back then, the two space probes, Voyager 1 and 2, left our blue home planet to provide us with groundbreaking information about the outer planets of the solar system, which were still largely unexplored at the time today. Some 45 years later, the two unmanned spacecraft are still moving through the gigantic expanses of space and have meanwhile gone toe-to-toe with interstellar space, and although the probes are already many billions of miles away from their earthly home, they are still transmitting informative data in the direction of Earth. Much of this information has already helped us to significantly deepen our knowledge of our galactic neighborhood, while the probes have already given us some unprecedented insights into the mysteries of the cosmos. Thanks to Voyager 1, we now also know what the remote realms beyond the solar system sound. Like in today's video, we'll show you what the strange humming sound is that the probe captured last year and what other exciting topics are keeping researchers on their toes, interested in learning more about the groundbreaking discoveries and unique spectacles in the universe on a regular basis. Then remember to subscribe to Simply Space and click the bell to stay up to date from now on. Go ahead and show us with a thumbs up that we can keep you engaged with the content of our videos overseas. Music, the unfathomably large distance that currently separates us from Voyager 1 is over 15 billion miles. The sister probe, Voyager 2, which was launched in the late 1970s, was the only other man-made object to successfully penetrate as far into space as this one. The two probes first set out to examine Jupiter and Saturn in detail before Voyager 1 headed for the outermost regions of the solar system, but its journey had a few more stops in store. Voyager 2 first headed for Uranus before continuing on to the realms of remote Neptune. Since then, no other probe has returned to visit the two ice giants. In this final chapter of the exploration mission, some basic characteristics were to be examined, such as the strength and orientation of the solar magnetic field, the composition and energy spectra of solar wind and cosmic rays, the strength of radio waves, and the distribution of hydrogen in the outer heliopause. Last May, the headlines were filled with a mysterious hum that Voyager 1 had detected in interstellar space, but what was the context of this exciting journey? In detail, the interstellar medium, the matter, radiation, and magnetic field that permeate interstellar space, or space distant from the stars, is the cause of this low, continuous hum. The galactic magnetic field with its plasma wave subsystem, electromagnetic and cosmic radiation, and gas and atomic ionized and molecular form, as well as dust, are the most significant components of this medium. Voyager 1 examines the matter there closely, and the measurements showed that there are frequent disruptions of the plasma waves, which are caused by the solar wind. However, in between these outbursts of activity from our host star, there is a steady plasma calm that shows up as a persistent, faint hum. In this context, the researchers say that the interstellar medium is like a quiet, gentle rain. As a result, the solar winds that happen frequently have the ability to interrupt lightning strikes that are transmitted to Earth in a narrow frequency bandwidth. The ominous hum was so faint that it could only be heard with special processing. Additionally, the data that has been gathered thus far indicates that interstellar gas and such lulls occur much more frequently than experts had previously believed, despite all the greatness, histories, and insights that need to be deciphered and obtained in the future. The two Voyager probes continued their journey unabated around 2025. The spacecraft will stop their scientific activities in the 2030s, at which point the space probes will be so far away from our blue home planet that contact is no longer possible. But this does not mean the end of their journey unless there are unanticipated complications. In almost 40,000 years, Voyager 1 will pass the Starkleys 445 at a distance of 1.6 light-years. According to the expected 500 million-year lifespan of the renowned Voyager Golden Records, which departed Earth with 2 space probes, the Voyager probes may still be able to provide evidence of our past existence even if the human period has long since passed. Secret lunar caverns. Neil Armstrong and Buzz Aldrin became the first humans in history to set foot on a foreign celestial body on July 20th, 1969. 10 more astronauts were scheduled to land on the Earth's constant companion after the first moon landing, but the last manned expedition to our satellite was nearly 50 years ago. However, several countries have plans to change the situation in the near future. During the future missions, permanent lunar stations will be established, and lunar raw materials will be mined in order to achieve these ambitious goals. Massive. Resources like electricity, water, and breathable air are needed, but these aren't the only challenges the specialists confront during the planning process. They also need to locate a good site for the lunar outposts, which must fulfill a number of fundamental conditions. We should not ignore the extreme temperatures during the day, when the moon's thermometer reaches nearly 250 degrees Fahrenheit, and the nights, which are marked by bone-chilling cold with temperatures of nearly -275 degrees. Adequate protection against radiation and meteorite impacts is also crucial. Possibly, the answer to the question of choosing the best location is hidden namely in underground passages and caves once formed by fast-flowing lava flows. In fact, some probe images suggest that such a hidden lunar world actually exists in detail. This refers not only to winding depressions but also to so-called skylights, almost circular depressions that could be the result of collapsed cave ceilings with a diameter of between about 50 and 500 feet. The skylights could therefore represent the gates to huge underground cavities. But what would the temperatures of these lunar cave complexes be like to get closer to answering this question? A team of researchers took a closer look at one of these skylights. This was a collapse hole, about 300 feet deep near the lunar equator, also 300 feet in diameter. The first task for the scientists was to evaluate the data from the thermal camera of NASA's LRO lunar probe. The researchers then fed these data sets into physical models of heat conduction and obtained a surprising result. According to this, the temperature data of the skylight deviates significantly from the values of the surrounding surface during the day. The bottom of the pit gets up to more than 280 degrees Fahrenheit. This heat is not only due to solar radiation, but is also formed by thermal radiation from the walls. In view of this knowledge, one could think that the establishment of a manned station in a lunar cavity is out of the question, but this is not true, because actually pleasant temperatures prevail in the areas which are not subject to direct solar radiation. According to this, the cave adjacent to the pit would be about 63 degrees Fahrenheit, and that, with an amazing constancy, the principle is that the larger the cave adjacent to the skylight, the more constant the temperatures remain during the alternation of day and night. So, in principle, such caves could provide excellent conditions for establishing a permanent lunar base. In addition to the comfy room, temperatures protection from impacts and radiation would also be guaranteed there before we get that far. However, the caves must first be comprehensively investigated and above all confirmed. If the air-conditioned shelters are, indeed, discussed as sites, their in-depth deciphering could be a worthwhile endeavor. A future lunar landings glass Z13. To conclude our video today, we would like to take another brief look at an exciting discovery made by the James Webb Telescope. As we all know, one of the main goals of this complex piece of equipment is to detect the earliest galaxies and luminous objects in the universe, although the scientific mission of the most sophisticated space telescope of all time has just begun. It has already impressively demonstrated its unparalleled capabilities. In fact, Webb recently succeeded in identifying one of the oldest galaxies ever discovered at its core. This gravitationally bound collection of stars and company goes by the scientific name glass Z13 and was formed just 300 to 400 million years after the Big Bang. This makes the newly discovered galaxy another 30 million years older than the previous record holder, HD1. Now, we want your opinion. What do you think about the Unicom captured by Voyager 1 in interstellar space, and what do you think of the plans to build the lunar stations of the future in lunar caves, as always? Drop us your thoughts, suggestions, and feedback on today's video in the comments below. Are you in the mood for more exciting contributions on the topic of outer space? Then take a look at the other videos on our channel, which you can access by clicking on one of the images in the credits. We appreciate your attention. Be careful, and we'll talk to you soon.